Bond enthalpy and enthalpy changes. Energy is absorbed when bonds are broken and released when bonds are formed. Atoms tend to be bonded to other atoms in order to become more stable. Chemical bonds are the result of electrostatic attractions between atoms or ions. In order to overcome these attractions, or to break the bond, energy must be absorbed. In other words, bond breaking is endothermic. Conversely, when new chemical bonds are formed, energy is released. Therefore, bond making is exothermic. The difference between the energy absorbed and the energy released can be used to calculate the overall enthalpy change for the reaction. The energy needed to break a bond is called bond enthalpy, or bond dissociation energy, E or H. It is defined as the energy required to break 1 mole of chemical bonds in the gaseous state. Bond enthalpy values are always positive because it refers to bonds being broken and thus represents an endothermic process. It is also important to note that bond enthalpy values are generally only valid for gases. In most cases, average bond enthalpies are used, where the same bonds in different molecules have different bond enthalpies, so these are averaged into a single value. The table shows some common bond enthalpies. These values are used for calculating enthalpy changes using bond enthalpy values. The enthalpy change for a reaction can be calculated using average bond enthalpy values, and all bond enthalpy and enthalpy change values are in units of kilojoules per mole. When the enthalpy change is positive, it means that the reaction requires energy to occur, such as when breaking a bond. When it is negative, the reaction produces energy, such as when a bond is formed. The following example would give a better understanding of this process. Calculate the standard enthalpy change of combustion of propane, given by the equation and the following bond enthalpy values. There is some knowledge of molecular structure needed in order to complete this question, but it shall be addressed in another video. There are 8 carbon-hydrogen single bonds, 2 carbon-carbon single bonds, and 5 oxygen-oxygen double bonds on the left side of the equation. There are 6 carbon-oxygen double bonds and 8 hydrogen-oxygen single bonds on the right side of the equation. In addition, there is a state change from gas into liquid. Thus, the calculation of enthalpy is as follows. 8 times 413 plus 2 times 347 plus 5 times 498 represents the energy on the left side of the equation. Subtracting 6 times 805 plus 8 times 464 plus 4 times 41 equals the enthalpy change. As noted, the 4 times 41 is the energy gain from a gas condensing into liquid. Thus, the enthalpy change is negative 2,218 kilojoules per mole. Thus, it is an exothermic reaction, as the system is losing energy. Thank you for watching the video.